For as long as we have had the motor car, we have dreamt of making it cleaner. The internal combustion engine, for all its magnificent noise and drama, has a rather messy habit of turning fossil fuels into forward motion, leaving a trail of unpleasant fumes in its wake. This has led us down many technical rabbit holes. We've fiddled with electricity, which is fine until you realize the batteries are heavy, expensive, and require a rather tedious wait to recharge. We've also had a go at hydrogen, which is splendidly clean but frightfully complex and costly to produce and store. But what if the answer was simpler, cleaner, and all around us? What if a car could run on nothing more than the very air we breathe? This is not some far-fetched fantasy from a dusty science fiction novel. It is a genuine engineering concept, one that taps into the fundamental principles of physics. The idea is wonderfully straightforward. You take ordinary air, compress it into a tank until it is under immense pressure, and then release it in a controlled manner. This expansion of air can be used to push pistons, turn a crankshaft, and ultimately spin the wheels. It is in essence a steam engine without the fire in the boiling kettle. The only thing that comes out of the exhaust pipe is cold air. No carbon dioxide, no nitrogen oxides, no fuss. It is the sort of beautifully simple idea that makes you wonder why it hasn't been done before. The appeal of such a vehicle is immediately obvious. Imagine a world where refueling your car is as simple as plugging it into a high-pressure air compressor at home or at a service station. The process would be quick, much faster than charging an electric car, and the fuel itself is free. There would be no reliance on vast, environmentally questionable mining operations for lithium or cobalt. Nor would there be a need for a complex and potentially volatile hydrogen infrastructure. The car would be almost silent, gliding through city streets with only a gentle hiss to announce its presence. It represents a sort of mechanical purity, a return to basics that is deeply attractive in our increasingly complicated world. This vision has captivated engineers and inventors for decades, but it has always been held back by some rather significant practical hurdles. The challenge, you see, is not in making a car move with compressed air. That part is relatively easy. The real trick is making it move far enough to be useful. Storing energy in the form of compressed air is not nearly as efficient as storing it in a tank of petrol or a chemical battery. But back in 2011, a group of very clever people at Toyota decided to have a proper go at it. Not to build a car for the masses, but to see just how far the idea could be pushed. And the result was something quite remarkable. Enter the Toyota Kurin. The name, which translates from Japanese, hints at its purpose, air car. This wasn't some polished market-ready product from Toyota's main production line. Instead, it was the brilliant creation of an in-house team of enthusiasts called the Dream Car Workshop. It was a passion project, a skunkworks operation designed to explore the fringes of automotive possibility. The vehicle itself looked like a streamlined, three-wheeled projectile, built for one purpose and one purpose only, to prove a point. It was lightweight, aerodynamic, and stripped of all but the most essential components. Its mission was to demonstrate that an air-powered vehicle could be genuinely fast. The technology at its heart was disarmingly simple. The Kurin did not have a complicated engine with thousands of moving parts. It used a tank to hold highly compressed air, which was then channeled to an engine that worked much like a reversed air compressor. As the air expanded, it drove pistons, which in turn powered the wheels. There was no combustion, no spark plugs, and absolutely no emissions. The only byproduct was a puff of cold, clean air. In a world increasingly obsessed with battery chemistries and charging protocols, the Kurin was a breath of fresh, unpolluted air, both literally and figuratively. It was a testament to pure, unadulterated mechanical engineering. And it worked. Oh, how it worked! In 2011, the Kurin set a Guinness World Record for the fastest compressed air vehicle, reaching a staggering speed of 129.2 kilometers per hour, or just over 80 miles per hour. This was a monumental achievement. It proved that air power wasn't just for novelty toys or slow-moving industrial equipment. It could deliver genuine, exhilarating performance. The initial reaction was one of widespread excitement. Here was a major automotive manufacturer, Toyota, showcasing a car that produced zero emissions, made almost no noise, and was shockingly quick. It seemed for a brief moment that the future of mobility had arrived, and it was powered by nothing but air. Of course, this initial wave of enthusiasm was built on the spectacle of its speed. The headlines celebrated the record-breaking run, painting a picture of a silent, eco-friendly speed machine that could revolutionize our roads. People imagined a future free from dependence on fossil fuels or rare earth metals, a future where our cars were as clean as the air around them. The Kurin became a symbol of what was possible, a tangible piece of evidence that radical new ideas could challenge the established automotive order. However, behind the impressive top speed lurked a rather significant and inconvenient truth, one that would keep the Kurin firmly in the realm of experimentation. For all its blistering speed and eco-friendly credentials, the Kurin had a colossal Achilles heel: its range. After its record-setting sprint, the car could only travel a total distance of 3.2 kilometers, or about 2 miles, before its air tank was completely empty. This, you will agree, is not very practical. You could just about manage a trip to the local shops, but you would need to refuel for the journey home. The problem lies in the low energy density of compressed air. A tank of compressed air simply cannot hold as much usable energy as a similarly sized tank of petrol or even a modern battery pack. This limitation made the Kurin a fascinating proof of concept, but a non-starter for the consumer market. Toyota never intended to sell the Kurin. It was an engineering exercise, a project designed to push boundaries and gather data. It succeeded magnificently in that regard. However, its failure as a practical vehicle did not mean the end of the road for compressed air technology. On the contrary, the project's legacy was to inspire a different, more pragmatic approach. Engineers realized that if air power couldn't be the star of the show, perhaps it could be a brilliant supporting actor. The idea shifted from pure air-powered cars to hybrid systems, where the unique advantages of compressed air could be used to enhance the efficiency of existing powertrains. This new line of thinking led to some very clever innovations. In Sweden, for example, engineers developed a hybrid system that used regenerative braking in a novel way. When a conventional hybrid car brakes, it uses an electric motor as a generator to capture kinetic energy and store it in a battery. The Swedish system did something similar, but instead of charging a battery, it used the energy to run a small air compressor, storing the captured energy in a pressure tank. This stored air could then be used to provide a power boost during acceleration, reducing the workload on the main engine and significantly cutting fuel consumption and emissions. This hybrid application is where the true genius of the Kurin's legacy lies. It revealed that compressed air systems have distinct advantages. They can capture and release energy very quickly, much faster than a battery can charge and discharge. They are also simpler, lighter, and potentially much cheaper to manufacture than complex battery and electric motor systems. They don't degrade over time in the same way batteries do, and they are made from common, easily recyclable materials. The Kurin may have had an impossibly short range, but it pointed the way toward a future where its underlying technology could make all cars, regardless of their primary fuel source, a little bit better. Fast forward to today, 2025, and the conversation around compressed air is bubbling up once more. The automotive world is at a crossroads. While battery electric vehicles, or EVs, have become the default vision of our green future, they are not without their problems. The supply chains for lithium and other essential battery materials are fragile and often ethically compromised. Battery production is energy intensive, and questions remain about their long-term recyclability. Furthermore, hydrogen fuel cell vehicles, another promising alternative, remain stubbornly expensive and reliant on an infrastructure that is yet to be built. It is in this context that the humble air car is getting a second look. The primary drivers for this renewed interest are cost and resources. A compressed air system is mechanically simple. It consists of a tank, some pipes, and an engine or motor that is far less complex than its battery electric or hydrogen counterparts. It requires no rare earth elements, no volatile chemicals, and no complex electronics to manage battery health. As we look towards a future where millions of clean vehicles are needed globally, particularly in developing regions with limited capital and unstable electricity grids, the appeal of a cheaper, more robust, and resource-friendly technology becomes undeniable. The logic that made the Kurin a fascinating experiment is now making its descendants a serious proposition. The hybrid applications pioneered after the Kurin are now more relevant than ever. Imagine a mild hybrid petrol car that uses a compressed air system to capture braking energy. Such a system could offer a significant portion of the fuel savings of a full battery hybrid, but at a fraction of the cost, weight, and complexity. This could be a vital stepping stone, making cleaner transport accessible to a much broader market. Rumors are swirling that Toyota is preparing to unveil a new secret project as early as November 2025, and many in the industry believe it will involve a significant advancement in compressed air technology, likely in a hybrid form. The Kurin, once a curious footnote in automotive history, may well be remembered as the catalyst for a quiet revolution. It challenged the assumption that our clean future had to be exclusively electric. While it is unlikely that we will all be driving pure air-powered cars with a 2-mile range anytime soon, the principles it championed are set to become a crucial part of the mobility puzzle. By offering a cheaper, simpler, and more sustainable way to capture and reuse energy, compressed air technology could complement, and in some cases challenge, the dominance of batteries. The car that ran on air dokazal, to inogda samye prostye ide mogut, bad samimi moshchnimi.